How we doing? Have we got a microphone today? Yes, we have. Have we got pictures? Oh, amazing. How we all doing? God, isn't it hot? It is so hot. Right, who we got then? Let's have a look. I think we had in Tim and Aaron first. Kim's dropped in. Kim's still with us, I believe. Joe's in. No, let's do that. Computer shouting at me. So Kim's in, Tim, Bob's in. Long wave TX module video. Yeah, I did sort of, I didn't watch it all, Tim, but I don't know if you I think you left it at 200 kilohertz, didn't you? But that was the original long wave frequency, to be fair. Ricardo's in. Hi, Ricardo. Nick's in. Hi, Nick. Who else we got in? Just going down through the chat. I don't think I missed anybody so far. Baz is in. Hi, Baz. Anthony. I tell you what, I've had the aircon on, but I keep turning it off because it's so blimmin' loud. You can't hear it, apparently. I couldn't hear it when I played the video back, which is really strange, but this mic must be doing a wonderful job. Alex, how are you, mate? A nice cool breeze coming off the North Sea today. Yeah, it's not so cool here. Alex, to be fair, it's blimmin' baking hot. Derek, how are you? Good timing, mate. Multi's in. Oh, hang on, we did a bit of a jump there. Multi's in. 30 degree, yeah, it's supposed to be 30. Well, I can tell you what it is here at the moment. My weather station's died, so according to this, hang on. If I refresh it reckons it's 28 here now, but I'd challenge that, to be fair. It's supposed to be getting up to 30 shortly at, well, between 3 and 4. But it is baking hot here. Foolishly enough, myself and Mrs. Cruncher on Friday decided we were going to go and start painting and, well, interior painting. It was unbearable. How we didn't pass out. We're both suffering still for doing it now. Foolish, really, but there you are. Benji's in. Hi, Benji. Andrew, little boy. Hi, Andrew. I think I've got everybody. Ceiling fan. Now, the problem is here, to run the aircon properly, I've got to shut the door. And if I shut the door, it's like a little oven in here. I don't know what the temperature is now. Let me stick it back on again because I'm warming back up. Whew, dear. Yeah, I don't know why it doesn't come over the audio. I don't know. Danish, how you doing, Paul? Yeah, I'm upstairs here, so I would say we're definitely in the 30s up here. We just can't cope with it over here, can we? The heat, it's madness. It's absolute madness. So we've got very strange sounding beer today. Can you see this? Butty Back. I thought it was Butty Batch, but it's Bucky Back. Bucky? Butty Back. Wye Valley Brewery. Stone Lacey, Hertfordshire, or Herefordshire. Herefordshire. Is Herefordshire in Wales? Are we in Wales? So, yeah, I've not had this one for quite some time, and Mrs. Cruncher found that one for me, again, like she does. Butty Back. Well, the aircon is on. My hair's not quite flying away yet, but, you know, it's pretty wild in here. So you'll have to let me know if you can hear it. I did play the video back when we did the long wave live stream, and I couldn't really hear it after, you know, So pretty good. Right, let me see if we can find the butty back. Butty back beer. It's made by the Wye Valley Brewery. So here we go. Butty back. Moorish Premium Ale. Now, I have had this before, but not for a long time. It looks like it was the 40th anniversary last year. Brewed in 1998 for the Great Welsh Beer Festival. So Butty back means little friend. Now, Derek's probably shouting that at me in the chat now. Marisota, Crystal Mo, Fuggles, Goldens, and loads of different hops in that then. Wow. Sweetness, bitterness. Available in cask or bottle. A beer that slips down remarkably easily. Hopfather. I think I've had Hopfather before. This is some of their other beers. Pioneer I've never heard of. Hopfather I think I've heard of. Wholesome Stout. Nightjar. Fandango. What's all that about? Hootenanny. Limited release. What's that then? I don't know. What's limited release? Oh, Miami Vice. Coming soon. Okay. August, they've got Canyon coming. Hops from New Zealand. Session IPA in September. Ghost Face in October. Charleston and Naughty or Nice for Christmas. God, oh, I can only get it in a cask. That's a bit of a shame, isn't it? Oh, retired? Should be me. Yeah, it looks like they're all cask or keg. What's the difference between keg and cask then? Wow, they've done quite a few, haven't they? Wow. There we are. Butty back. Beer. Whee! Good timing. Rob's in. How you doing, Rob? Rob's out watching a cycle race today, look. Towards AF127s, yeah. They're currently running about £7 each, aren't they? AF127s. Crazy money. Apologies if I'm shouting, but I'm shouting above the aircon. Mm-hmm. 127 transistor. £6.25. 5 for 21.49. That's probably not bad. The good thing is they're in sealed bags. The problem you've got getting some of these is people will go through them and they'll pull the ones with the best gain out. So you end up with rubbish gain on them. These are sealed. I've got some of these already. Spain. Trouble is a delivery price there, isn't it? £6.90. Nico, a pretty good company. So it's about £9.50, isn't it, for one of those? For one transistor. Can you believe it? JH Components. Now, I've used them a lot. They were really reasonable. AF, you don't want to buy new old stock AF 115s. They were really, really reasonable. AF 125, no 127s. They got 125s though. 525 each. So yeah, JH Components are pretty good, to be fair. Anyway, while we're here, we'll do our YouTube channel for today. Now, I don't know if I've already done this one. The problem is I've gone through so many now, I can't remember if I've done it. Have I done this one before, Learn Electronics Repair? Really enjoy watching this guy's channel. It's Richard, and I believe he's over in... Is he in Malaga or Spain, somewhere like that? Yeah, he's in Spain, but yeah, he's got like a little repair shop, and he does loads of videos on switch mode supplies, fault finding, all of that sort of thing. So yeah, switch mode power supply dead. Really, really clever bloke. Certainly got a northern accent. He's not Spanish. He's obviously an expat. So yeah, some really good stuff. If you want to learn electronic repairs, then he does some back to basics stuff. And he's also done a few projects that you can build as well. So yeah, a lot of videos. He's got a lot of subscribers as well. Makes my channel look poor, doesn't it? 222,000 subs, look. So yeah, really good channel. Link for that is in the description if you want to follow along. Brandenburg Concerto beer. Look grainy. It's probably because I've got the colour different. Plus it's a little bit dark. I've got the colour. It might be because the focus is changed. It's probably because the focus has changed. So I blurred the background a bit more because it was all sort of like blending into one. Trouble is I've got to sit still and in the right place, Anthony. Don't have, I can fit a cask in, I'm sure. Joe, I'm sure I could. It is for an AF127, Abbas, yeah. The AF117s are in a different can. Bit hairy hands. Yeah. Yeah, Buzz, I've watched him before, Derek. It's a bit bizarre, that, for me. Isn't that the chap that does lots of glove puppet type things? Anyway, this beer has actually been in the fridge. So you can see it's got a, well, it's got a little bit of condensation left on it, look. But it was too hot to have it out on the side. You know us Brits love our room temperature beer, but to be fair, room temperature at the moment is up in the high 20s, which is not a good temperature for beer. I would have thought sort of like 15, 16 degrees is fine, but once you start getting up into the 20s, it starts getting a bit, yeah. But then if you go too cold, it tastes weird, so you can't win really, can you? A decent head on it, nice. Anyway, cheers everybody. Let's have a good, let's see if we can fix this radio. Is it broken even? I don't know. Yeah, it's got a nice taste to that. Not overly strong at 4.5. Thank you, Kim. Not overly strong at 4.5, but now I've got some damp all over the table. I don't really want to soak that up in the case. Just condensation off of everything. Let's move this forward a little bit then. So you can tell it's a typical sort of 60s radio. It's in this sort of like imitation leather case. Early PVC. And it's sort of start peeling where it curls, where it curves. But being it's inside this case, and I've looked on Radio Museum and they haven't got any that are in the case or in any of their pictures. So I must pop a picture of that on Radio Museum. Give me a bit more cred on there. Stephen, yeah, of course it is. Of course it is. You can transmit into it from anything you want. So we did a little bit of that the other week, didn't we? When we did the long wave session. I have got to edit a video to put the DAC 90A out for that. So yeah, you can get a little pantry transmitter so you can transfer it. They are pretty much identical, Baz. I think some of them work slightly different at different frequencies, but they're pretty much the same. You can use any of those in place of an AF117. So let's have a look at what it says about this then. So this is the trader sheet from 1966. Now, Radio Museum, if I go to their page, they seem to think it might have been 1963. Well, the trader sheet says 1966. I don't know. If you look at their pictures, oh, it's kicked me out again. You know, none of their pictures have got the case. Someone's got the box there, which is quite nice. This is weird because you can't click on it because the bloody thing's in the way. What's all that about? Yeah, so someone's actually got the case for one there. Look, so it's called the Strand PR44. Nice to have the case, though, isn't it? I mean, that's 1966 case. Not case, you know what I mean. So this is a slightly different one, different color version. So you can see our 3 AF117s in there. And this is the one that I've got, although this looks very orangey, so that's a bit blown out. Certainly mine's in pretty good nick. Pretty good nick. Let's cancel that, so we don't need that anymore. Let's zoom you out a little bit. There we go. Yeah, certainly worth going, Stephen. Your mate had one of these, did he? Look deep in your heart, Aaron, and you'll see the answer. I like it, 8-ball. You tell him. You tell him where it is. We didn't actually look at that sheet, did we? I got that up and we didn't physically look at that, did we? That was a bit silly, wasn't it? Okay, let's do that again. So it is from 1966. It says 7 transistors on the front. Sure enough, it has got 7 transistors. And these are quite good, these trader sheets, because it does go through the circuit description over here. So it tells you how it works pretty much. Medium wave and long wave. And if you look down here, you can see the 2 different circuits for medium wave and long wave. That's the ferrite for medium wave, that's one for long wave. It goes into this transistor here, which is a mixer oscillator. This is a little oscillator circuit over here. Up through into our IF stages. Only 2 IF transistors by the looks of it. I don't think this acts as an IF as well. Out through to the driver stage and outputs. Pretty straightforward. This is our AF117 pin out. I don't know what TR. No, hang on. No, this is TR1, 2, and 3. So I was trying to explain to Andrew which lead was which. You can see we've got a bigger gap here. So it's collector, shield, base, and emitter on the AF117s. There's a little layout of the board. Pretty much standard for this age, really. Takes a PP9, 9-volt. Circuit alignment. It's pretty straightforward. The only problem you've got with these is all these coils have got really dodgy cores in them, so you need the correct tool or just leave it alone. If it's working, leave it. We've got quite a few electrolytics. Is there any critical ones? We've got a few that go to ground. So we got positive ground on this, as I think Tim said. AGC comes around here, so C8 is going to affect the signal. That's not really. Yeah, C22 is in the output stage. I'm just trying to see if we've got any more across the. Normally this is just one right across from positive to negative. It doesn't look like there is on this one. So yeah, they are. Not much to it really. We'll refer back to that as we need it. Yeah, a couple 4 months after. No, as I say, we can use a transmitter to get stuff on long wave, medium wave, so there's no worries about still using your old radios. Right, let's get this one out of his little case then, which is a bit nifty, isn't it? It's got some aerial sockets on the side as well, aerial and earth. And it's even printed, tells you medium wave and long wave. This is our volume on off. So I think I got this from the car boot sale. I think. Not the easiest thing to wiggle out the case, mind you. There. I suppose it is a bit orangey, isn't it? But I think that might be just where it's got the sun, you know. You see underneath it's a fair bit redder. So it might benefit from a retro bright, and the back is very yellowed. You can see how yellowed it is. So that definitely is worth having a bit of a go at retro bright in it. So we've got Perdio written on it here. Little Perdio logo. 7 transistor. We've got the usual sort of 60s stations on here. So we've got the light station instead of radio 4 on 1500 meters, which is 200 kilohertz. Alui, Europe 1, Oslo, Luxembourg, and Moscow. None of those are about anymore. And up on medium wave was quite a few. Third, light. Just trying to see if there's anything. AFN? Where's that? Anybody know what AFN is? Got any AFN fans out there? Not sure on AFN. Brussels, Hilversum, Welsh, London, Midland, Light, Western, Luxembourg. So Luxembourg was available on long wave and medium wave then. Didn't know that. I probably did know that, but I forgot that. I forgot more than I've learned, to be fair. Let's get the back out and we can get some power on it. Just a sort of thumb slot for that. Made in England. I think it says that. Made in England. Not much these days. It's made in England. I think our American friends, everything was made in Hong Kong, I think, wasn't it? For some reason, they were absolutely inundated with Hong Kong stuff, weren't they? Oh, hang on, you got to pull the handle up to get the back off. So I'm sure you can see all the goodness in there. Let me get you in with the overhead camera and we'll see where we are. If it's working, yes it is. Oh, very good, very good. So I'm going to concentrate on the board. Let's go in a bit closer. So what have we got? What have we got? C11 Bob peroxide for my hair. Steel City Stephen, how you doing, mate? Or Sheffield Steve even. American Forces Network. Armed Forces Network. Oh, right, okay. Is it American or armed then? So what have we got? We've got an AF117. I take it this is the first transistor. Let me just have a look. Layout. Yeah, that's TR1. So that is a self-oscillating mixer. TR1. Then we go through, I think that's IFT, first IF can. Yep. IFT1, then we go to TR2, another IF117 into our next IF can, IFT2, then through our next one, another IF117 into IFT or IF transformer number 3. Then we're out into our output stage. Got a little label in there as well that says it's been inspected. No signature on that though, on the inspection side. It's had a couple of stamps on here, that. T61 INS 56. There's also another number just here. Another inspection number says INS 75 or 76, not sure. Not really sure of that. So we've got lots of caps here. These are the old Phillips caps, so they're usually not too bad, although this little one here, these little ones are normally no good at all. They dry right out. So here's our output transformer. Here's our output transistors. Volume pot. Band selector and our tuning cap. Trimmers from long wave, medium wave up here. I'm not sure which one of these is the detector. Oh. I think it's the earlier one, isn't it? D1 is the detector. And that is, oh no, it's D2, which is in this can. Yeah, in that can, the detector. Sure what that one is over there. That's D1. Or is that a detector? I'm getting confused now. So apparently it's a damping diode, that one, D1. A damping diode. Yeah, it's across. Yeah, so definitely D2 is the detector. That is inside that can. It says Perdio on the back of that, right? Perdio Electronics. Bon Hill. EC2. Where's EC2? So, the East End? I don't know. So we got some potential issues with these AF117s, haven't we? Output stage should be all right. OC71s, is that an 81D or an 81? 81D, and that's OC81s for the output. I think with a bit of tappy, this will work, you know. What do you think? Who thinks this is going to work? That's Danish has typed in a farts. A farts for short. Does look quite clean, Tim, doesn't it? And the other thing that had happened, and I've rectified one, is the only thing holding it in was this pillar here. There's a screw missing from here, and there was a screw missing from here as well. So I've managed to find one, but these are Imperial screws. I've got nothing that fits them. This came out of a very old 3-pin plug. So I've got no Imperial machine screws. So yeah, I found something to go in there, but it's not great. So if anybody's got a nice supplier of Imperial small machine screws, I think they were number 1, number 2, number 3, number 4, that sort of thing, weren't they? I think. The AFM was provided for the troops deployed in West Germany back in the Cold War. Thanks for that, Bob. Magic hammer, yeah. I don't think so. I think someone was having a laugh there, Baz. Ganesh, how are you, mate? Get some more butty back in me down my neck. Right, power supply. Let's hook her up. Place your bets. Will it or won't it? Will he or won't he? Will he or won't he work? Will there be any smoke coming out? Fire in the hole. Can hear audio, but no RF. What are we on here? Medium wave. Can't hear any RF. So let's get the de-whiskering hammer out and give it a little whack. See if we can't breathe life into it. So we've definitely got an audio stage. Let's get a little screwdriver. Well, first one, look. Wow. It's working. The outlaw. No silver bridges yet. Don't talk to me about silver bridges. Let's whack an external area on that.
Well, having played a Australian Open final and big Davis Cup ties, and pretty well. But you know, I did my routine, which was to get up in the morning, get with my fitness trainer, and go run to the park, do some sprints and agility, then get in the car. And somebody used to drive. They didn't trust me my driving skills, which was probably sensible. The last thing you want is road rage at when finals day. Then come here and warm up for an hour. So I was at the opposite.
It's not working very well without assistance,
which are not exactly all white. We put them on for like 1 minute just for fun. And then, yeah, I like to warm up really close.
It's Radio Wales, I think. Wales.
Is a birdie. Super. That's not a bad description.
I haven't heard that one before. I've been called lots of names, but not that one.
And Russell, Tim mentioned this at the start, but we've got the top two Cs. We've got the two best players in 2026 in terms of results, fighting it out for the Wimbledon.
So, it is working. It needs assistance. Without the assistance, I don't think we can get anything really. We've got a bit of a dodgy volume pot. That seems a little bit wonky. So, obviously, if we've got shorts on the AF 117s, that is going to affect reception. So at least we know that we can't get any reception without assistance. Saying that, that's like a lot of radios in this room. You're going to struggle to get any reception on AM without a bit of assistance. It's nice. It's nice, Steve, isn't it? Time to get it out of the case, because we have some zapping to do. Do we need to change the capacitors? I mean, the audio caps are normally the ones, but to me that sounds really, really good audio. So I don't think we need to mess with those. Where's the correct screwdriver? I drop that on the floor. No, it's there. So there's not a lot to this. We've got this screw here. And got this one here, which is from my plug terminals. and it's not magnetic because it's brass. We've also got a couple little aerial connectors in here, look, to connect that external aerial. So to get them off. Then look at that. Out she comes. So think, should I take the whole lot out in one? Or should I just disconnect those two wires? Probably easier to just disconnect those two wires, isn't it, really? Then I'm not going to have the speaker and that plug hanging off. Let's take a quick picture of where that goes. Do-do-do-do. 29 degrees now, but nice and cool in here. Let's get that down there. Be careful with this because it's a plastic case. This grill needs to come off to be cleaned as well, so I'm going to stick that in my ultrasonic later, and I'll stick the back panel in my retro biting retro brighting box. So we're certainly down on performance, being that I've got to pull that other aerial in, but it's working well, really, to be fair. So we could do a little experiment, and we could desolder the shield wires from all of these transistors, see what difference that makes. So which one is which? Which way have they wired these? Have they used the red as the collector? I think they have. So it looks like the red is the collector. We get back in on the overhead camera again. So yeah, it looks like red is the collector. So the one next to the collector is a shield, so that's the one that we need to desolder. So we desolder all those three and just see if it improves the reception. Worth a shot, isn't it? As my sucky sucker gets up to temperature. Sucky suck suck. Lots of plastic things in the way. Although that front is aluminium, so it is. I believe that's typical. This thing here is in the way now. So it looks like we can take this front plate off. Can we? Without the dial cord jumping off? Scary. Yes, we can. That's handy. Right, that means I can get into here now. So I think the one that I want is this one here. It's right by the dial cord as well, so that's going to be a bit tricky. So again, this has got like plasticine traces on these boards. This is this old brown material. Is that off or not? That's that one off. I would have to take them out to zap them anyway, but I'm just seeing if this improves the matter. So this one here next. So that is I think that's the negative there. Yeah, there I think. Okay, so they've got multiple wires attached going through the same hole. So we've got, I think this is it here. Again, we can't dwell too long on the trace because it's going to lift it. Go on up there. I think that's it. Yes, it is. All right, so I need to just make sure that's soldered back onto the board. Okay, that's two of our grounds removed. The last one is this one here, which looks like nice and easy. This one. Can we come up nicely? That lifting any track? Nope. Again, I think we've got two wires in the same hole again. So this type of wiring is a little bit different because it isn't really a track. So that one actually has got a track, so I'm going to lift that one out. But the others are sort of adjacent to the pads. So there we are. Doing. Okay. Let's get the speaker back in and hook it up. Let's see if we have got any stations now. If we haven't, then we could be looking at some electrolytics as well. But bearing in mind this is an old radio and it's not great, and I'm asking a lot in this little room because it's proper RF block in here, especially with the aircon on now. Okay, that was going to go to there. We get it to go on there without shorting on anything. There. We want our positive and negative. Let's fire it up. I can just about hear it there. Okay. So if we tap the transistors now, no difference. So we've basically removed all the shorts from them. I've got the wrong camera. I've basically removed all the shorts from them. Yeah, so we have got other issues then, potentially. Could be the IF needs tweaking. But whatever, we've got to zap those transistors, because it might still have partial shorts across the other terminals. Might be that one's shorted and letting the signal through and the other one isn't. Turn your older soldering gear down to 300 degrees. Yeah, mine's on 350 bars. So let's just disconnect this. Just going to take a picture of each of the transistors. Let's number them. I like to put a little number on top. Oops, 110. So we know that was number 1. Number 2. And number 3. That way we won't need to do the IF cans necessarily. One, two. Luckily, they've pretty much put them all in line. So as long as you get the collector in the right hole, then the rest should be easy enough. So let's take the rest of them out. You gonna play? Obviously not. Whoa, this is dangerously close to the. Woo! No, that's not the right one, I don't think. No. Just caught the little pointer there as well. Only a fraction. Hellish difficult. What's that one to? That's actually underneath the tuning wheel down here, the other one. God, I can't get in there. That's dangerous. What's going on with this then? Right, let's go in with the soldering iron. Let's see if I can get in underneath here. Just move that one, just like that. There we go. That's that one. That one. Like that. Is that loose now? No, I don't think I've got the right wires, you know. I think this one might be one here. Can't work out which one's which because of the way they've wired this thing. Is there another wire in there? What? It's not. That's that one. This is fun. Okay, so no, that is not it there. That is a capacitor there. That is a capacitor there and there. So let's just solder that one back on. Didn't need to come off that one. So there and there. That's capacitor. It's that one. Yes. All right, well, so I desoldered there. Yeah, that's capacitor as well. Either something's flying around my legs or got something hanging off the bench. So that's also a capacitor. So far, I've only managed to desolder one leg on this. It must mean that they're these. That one. That one. Gets off. Definitely that one. That's one. Yeah, and that one. That's three. Where's the other one then? Is it this one? Yeah. Wow. They're well spaced out. They're well spaced out. Let's see if I can get you on the overhead camera a minute. Let's get in closer. Can you see where they are? Look. They're spaced out all over the place. So that must mean this one goes. Hang on, where does that go? Oh no, here we go. Did that one come come off of there, or did it come off of there? So that went there, that went there, that went there. Where'd this one go? Oh no! And where does this go? What is that? Is that this one? Yeah, that's this capacitor. So I'm going to have to work that out, aren't I? Oh dear. Yes, I'm not sure which wire goes where now. That's fun. Took all the photos as well, but you know. What is this back here? This is clearly not right either, so that's got to come back onto there. These boards are a nightmare because the holes are next to the pads. They don't go through the pads. Luckily, we've got the diagrams and we've got the circuit for it, so it shouldn't be too hard to figure out, should it? So this is one that we've got the problem with, which is C5. So does C5 join the collector of TR1? No, it doesn't. TR1 collector joins L5. Which is this one. So that one must go onto that one then. What a nightmare. That's straight away a pain in the backside, that is, isn't it? Definitely have got all four out now, haven't we? Yeah, right, let's straighten them all out. We're gonna have to work this out as we go. So yeah, that has got to go to there. C5 goes between ground and something else. That's got to go there. So solder that one back there. Just got to remember we got to check the board. Take a picture of the board as well next time. Straighten these all up. Why they can't go through pads, I do not know. 2, 3, and the last one's there, number 4. Yeah, I'm gonna have to work that out. What a headache. Well, there we are. I think we're going to need to do these one at a time and put them back in one at a time. Otherwise, I'm never going to remember where they go. Sharpie and Battery Maker, how are you doing? You hear the blue caps speaking, Outlaw. Yeah, I think you're right. They could well be part of the issue. Installing a problem. I'm installing a problem. So the radio is working. It is deaf as a post. But then, is that just this room? That's the question. That is the question. Right, let's have a look at this this transistor on the meter then. Go back to the main camera. Oh, did I have stream ending then? Whee! Beer time. It's Kim. So, the rule on these is there should be absolutely no resistance between the second wire in, the shield, and any of the other. It should just remain open. So, let's get him on the deck so you can see it. So, well, we can use the can because the can is connected to this wire here. Look. So I'll stick my probe on there. So it should remain like this. So no short there. No short there. No short there. Wow. That one has got no shorts. That's surprising. But we'll still zap it because we all know what happens if we don't. So to zap it, what we need to do is we need to ignore the shield wire. So we'll bend that one out of the way for a minute. We solder these three wires together. Base, collector and emitter, leaving the shield hanging out here. So joining all three junctions, and we're sending current between the junctions and the shield or the body of the transistor. What could go wrong, eh? Lots. We could blow the transistor totally, which is always a risk. I've done this for a long time actually. So now all three of my wires are together. You need to make sure they are because you will blow it up house. So I just need to configure my power supply now. So what I'm doing is I'm ganging it together. So as I can double the power. So I can basically chuck up to 60 volts through this at whatever I decide to do current wise. So I've got to remember, it's a long time. When was the last time I zapped a transistor? It was a long time ago. So we need a capacitor, and what I tend to do is I'll solder the capacitor to the shield wire. Or the negative to the shield wire. So then the idea is you charge this cap and then you touch it to there, and it zaps it basically. So let's pop my thing on. Let's even it out. Let's whack the volts up pretty high. Let's go 50 volts, look. I don't like to max this out. 50 volts. Then what we need to do is connect our negative to our negative. Positive to the positive. And then we zap that across. Hopefully it doesn't go bang. That is zapped. So that capacitor should still hold some power. You still got power in that? It's dropping off now. So the next trick is to solder the legs up overhead. We need to solder that to there. And we're just going to give it a good old whacking. Let's just take that off for a minute. Make sure they're all joined. You leave one of these legs off or it drops off, you blow the transistor up. So now the idea is we connect that up there, find the hole, and just get something like a screwdriver. We just want to tap this in case there's any shorts left near the surface. That just gives it a proper belt and braces job. We can get rid of the charge in that one. Sparks. Wow. Let's get rid of the shorts. Okay. Well, we didn't have any shorts to start with. So all we need to do now is just make sure that it is still a transistor. And the way to do that is with the transistor tester. So hopefully it's not died. They do die. So don't be too upset if you zap one of these and it doesn't survive. It's a 50-50 thing, really. There we are. Still a transistor. Very good gain as well. Very good gain. I'm just going to quickly check to see if there's any shorts on it. I don't think there will be, but again, the shorts aren't like a dead short. Very rare they're a dead short. They're just a slight reading. Obviously, that's the shield wire, so that's going to show us a short. Should be nothing on this one and nothing on this one. So that's a good transistor, that one. So we can pop that one back in. If I can work out where the hell the wires go to. Three. 1, 2. The problem is they bent all of these legs to get them through onto the traces. So we've got to bend them to get them back through the door. There's one that's decides it doesn't want to go. Okay, so you know that one goes to there. That one's only got there to go to. That one goes back onto there. And that one's on there. What could go wrong? Lots. Lots could go wrong. That's two. Right, let me get some eyes on this. Where's me goggles? Oh, I took them downstairs, didn't I, to sort out Maddie the other day. No, I disconnected another one underneath here as well, didn't I? Right. So I think we'll have a sense check and just make sure that still works. I think that's sensible at this stage. Actually, it's difficult because I want my power supply, don't I? But that should be okay. Just connect it using a battery. This battery's got power in it. Wood working. If the clip stayed on. That coil's loose as well, so that's gonna. Okay, so it might be that the coil was loose. Well, it is. The coil is loose on the board. So that we got that back in the right place. That's good news. That was worth just a quick check then. Let's catch up with the chat a minute. Let's see what's going on. Anybody else come in that I've missed? Is anybody lurking that wants to say hello? You're hoping for smoke. Trying to lay an ostrich egg. Oh dear. I think the higher the voltage, the better you're going to blow the shorts away, Baz. I've seen people doing it with 90 volts. Martin, how are you, mate? It has been a while. You've been on your holes, have you? Yoddy Toddy, welcome in, mate. Good to see you. Got a laptop. Sit downstairs. Yeah, it's warm over there as well, Martin, is it? Oh. Right, that's number one zapped. That was not easy. Okay. So the shield is there. Well, it can only go there, the shield. Signature. And we've got one over here. I think we have. There's loads of stuff joined on this. This one's going to be easier to sort, I think, from the end of the wire. Yeah, we thought Maddie had been bitten by an adder yesterday. She's a nightmare, Maddie is. She's into everything. It's going to go wrong. It's going to go wrong with Maddie. Right, that one's a lot easier. I can easily work out where that one goes. He says, famous last words, isn't it? So this is the first IF transistor now that we've got coming out. Transistor number 2. Right, okay, let's see if we've got any shorts on this one then. Take a photo, I know, you know. Let's see if we can get the light out of the picture. Let's just zoom you back out a bit a minute. A bit close in, isn't it? Right, so once again, I'm going to go on the can as my shield because it's connected to the shield. So let's first of all collector. So now you can see we have got, oh, it's disappeared. We have got a little bit of a connection there. .4 mega ohms, but there is something. So collector shield base. Again, we've got something there, and emitter. 4.7K, so that's that one has got shorts. Not a lot, but it has got shorts. So, you know, that's definitely going to affect reception. Let's just make sure that we're okay as a transistor, which, well, we know we are, but the radio is working. Let's connect it up. Ignoring the shield wire, of course. Again, good transistor, 233 HFE. We can, hang on, let's just connect that back up again. We can also look at the loss on it as well, the leakage. So 0.781. It's a germanium, so they've all got leakage. This is why people use them for these fuzz pedals and that, because they make a weird noise. I'm not really sure the science in that, but you know. So this one needs a zap, but it is at the moment still a transistor. Will it be after we've zapped it? I don't know. Let's hope so. So once again, we're doing this. Connecting the 3 together. I'm going to connect my negative on the cap to the shield wire. Then we're ready for a bit of zapping. So I'm going to do it the same as I did before. This is the way that I've always done it, and the way I've sort of seen it been done before. So I think the capacitor just acts as like a buffer, Baz. I think that's the theory behind it. So again, we need to make sure we get it the right way around. I've done this before and I've got the capacitor the wrong way round and it goes bang, big style. Hang on, whoa. Can you spot the mistake straight away? That would have died. Hey, Motronics. How you doing, Mel? Okay, we have an issue. So the second wire is a shield. But I've put it on the vector shield. I put it on the base. Just as well I check that. Just as well. Naughty, naughty, naughty. Very naughty. So that is the shield wire. That would have killed that dead, and I would be looking around for another AF117 then. Easily done though. Easily done. Always check. Right, now we're back in business. Try that again. Oh, I heard a little snick then. I heard a little snick then. So that's got, well, 50 volts gone through that at about 500 milliamps. Let's just discharge that. You got bang that time. Reconnect that. Lots of zapping and whacking going on. All right. Tapping again on this one. I don't normally short that out like that. I normally got a capacitor that I put across there. A capacitor, a resistor even, but don't know what happened to my little resistor collection. I'll just chop those across, I suppose. Naughty of me doing it like that. It doesn't do the capacitor any good. Doing it like that. So this is the test. Have we removed the shorts? Have we still got a short on there or not? Has this cleared them? Let's see. Nothing on the collector, nothing on the base. So that's gone. It's all gone. Just double check the meter. Yeah. So collector. Ooh. So all the shorts are gone. There is no more shorts. Have we got a transistor still though? That's the question. Have I killed it? What is happening? Here goes. Yes! And what's the leakage like? It was 0.78 last time, wasn't it? 0.704. So it's the same transistor basically. That was a success. So that was the first IF that did have shorts. Let's put that one back in. I think that was that way round, wasn't it? Let me just get my phone. We've just left the building. Let us remove your shorts. Yeah, so it was that way round. Collector, shield, base, missile. Can't really get those confused. So again, let's give it another sense check. Let's just reconnect it again. What's that come from? Oh no, that's not one of the pulleys. Yes, it is. It's one of the pulleys has come off of there. That's a bit naughty. Ooh. Luckily, it's held on there. Right. Let's make sure we're still working. Oh, hang on, don't do that, Graham. Oh, I nearly connected it to the power supply then. That would have been 50 volts going through it. Right. Yes. That's a bit better again, that is. Okay, one to go. One more Zapparoonie. One more Zappy Zap. This one. Number 3. Come on down. All right. So we've got one over here. We'll get the end of the wire. There's everything on the planet attached to that. Not everything on the planet's attached to that. So we've got the shield out. It's just this one then. Which is right on top of that one. Got it. So you can see that the hole is It's not on the pad, it's beside the pad. Very strange. I wonder at what stage they'd suddenly discovered, actually, no lads, we can actually drill through the pad and it'll be fine. See what I mean? One of the pulleys has come off the dial cord. That's a scary situation right there. Right, so look at this one then. What have we got? Nothing. 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 So it was only that one transistor that was actually shorted. Just double check that with the ground wire. Yeah. So it's only one that had a short. That's pretty good, isn't it? 1 out of 3. Check that it's a transistor. $199 HFE. You do find, I find personally that these have got better gain than the AF127s. So again, let's do it. I need to just do a little video on zapping these, don't I, really? Because a lot of people ask how it's done. And I always refer them to Mark Hennessy's brilliant article. But we will have another look at that in a minute because it's very well written, and I think Mark deserves all the credit for it. This is not my idea. I got this from other people. I've just done it my way, I suppose, and it does seem to work. And it lasts a very long time. I sold a radio to Mr. Man Cave Workshop, Sean, many years ago that I zapped, and a Roberts R707. And I don't know, it's when I very first started doing this. He's still got it and it's still going strong. So we shouldn't have any action on this one unless I got the wires wrong again, which I don't think I have. No, no dramas there. Turn that back off. I'll do that transistor resistor to just discharge that. Solder that onto there. Doesn't, you know, just because it hasn't got any shorts today, it doesn't mean to say that tomorrow it won't have. So it's worth doing this just to blast off any that are close to the surface, if you know what I mean. So another whack. Okay, we don't want to kill the transistor, really. Discharge that. Let's put my capacitor back to bed. Me zappy cappy. So let's just double check that we've still got a transistor. This one didn't have any shorts to start with, so I don't expect it to have any now. Hopefully it's still a transistor. Oh, hang on. Hang on. Have we got an issue? Have I killed it? Is it dead? Let's try that again. No. Okay, it is okay. Gained a bit of HFE as well, that. Right, let's pop that one back in. And again, just refer to my photo to make sure I know which way round it went. It's that way. So if you think about it, zapping that has saved me what? What's that saved me? That's saved me probably the best part of 30 quid, hasn't it? No. Say worst scenario, 20 quid probably for 3 new AF127s. Just by doing a bit of zapping, the quid's in. It's cost us nothing. Right, final go. Are we still good? Yes! We've already done it. Right, I need to go loo. I'll be back. I'll be right back. Right, we're back. We are back. Right, okay. George is in. What's George got to say? Let's have a look. Oh, I don't zap properly anyway, which seems to work, George, no matter what, whether it's proper or not. You charge a cap, then flash it across the leads. It was just smoothing the DC from the PSU. Yeah. You are right, George, of course. Yeah. Celebrity loo session. No worries, Aaron. Yeah, what I didn't do, Bob, is turn off the power. That's what George is saying. I should turn the power on, charge a cap, turn the power off, and then zap it across it. But to be fair, I'm putting the cap in circuit across the leads anyway, so it is acting as like a buffer, and it works. So let's have a look at Mr. Hennessy's article then. And I'll also stick the link to this in for you, because this is an extremely good article to read. So if you all want to get this up now, we can all read along together, can't we? So there's the link to the article. So, how to treat the transistor. Pass a high current through the tin whiskers so they're vaporized. Can we go in a bit? There we go. Yeah. So he's saying there that he's been doing this for a long time and he's yet to see a recurrence. I haven't either, although Rob says that the RP30 I did for him, I think it's the RP30, has got whiskers again. He seems to think, I don't know, it could be something else. So the basic idea is to pass a high current through the tin whiskers so as they are vaporized. So here's his method. Remove a transistor, measure the resistance, blah, blah, blah. Yeah. So connect together collector, base, and emitter, which we did. Find a decent electrolytic. So I'm using 100 microfarad, which is what he suggests. George obviously does it his own way, but at least 100 microfarads. the voltage rating depends on what you have available. So you could do it with some 9-volt batteries connected in series if you wanted to. Connect the bench supply to the capacitor, set the output to 0 volts. It says here, this power supply remains connected throughout the whole procedure. So that's my... I top up the capacitor if it loses charge. So I was right. Unless it says different down here, but it says it should be connected in case the capacitor loses its charge. Because end of the day, if you're putting these across it, yeah, okay, maybe we'll read further down. So you can see he's got his leads connected here from the power supply. Wind up the voltage. So it's still got it connected, look. So yeah, no, I was right. I was right. So take that back, George. I was doing it right, according to Mr. Hennessy's. So after you've done it, then you wind it down to 0 volts. So, yeah, I was doing it right. I thought I was. I'm not stupid. And then he basically reconnects it. So, yeah. I'm right, George. Sorry. Sorry to say it. Look at the picture and read number 5. I don't know, George. No, I'm right. It clearly says that it should be connected for the whole time. It doesn't say turn it down to 0. It's definitely correct, George. I'm definitely correct. So there you are. That's what I've just shown you is correct. I've read number 5, George. It works. I've done it hundreds of times, hundreds and hundreds of times, following that to the letter. It says nothing about disconnecting the leads and then shorten it onto it. Not to the power supply. The capacitor only solders one leg. Yeah, but that's what I did, George. I connect the 3 legs and the 1 leg, and then I touch them together. I've just done it. I'm sticking with it. I can't see what you're saying, George, but it works. I've just done it. I've just done it on 3 transistors. It's worked. Right, okay. Enough of that. But did I put the link for that in there? Yes, I did. So yeah, if you ever read through that article, see, make your own mind up. Make your own mind up. That's my interpretation of it. George has got a different idea. But you can do it with just charging the cap up and discharging it through it. But it clearly says that if you've got the power supply connected, it will stop the capacitor from being totally discharged. It will top it back up again. Okay, right. What are we going to do now then? What are we going to do now? We need to get this back on. This seems to have popped off now. This is a bit dicey. I don't even know if that was on there originally, whether I popped that off. We're gonna pop the dial cord here. Go on. Oh, back in business, right. Let's have a look at a couple caps then. Which ones are likely to be the dodgiest? Let's have a look at the circuit again. It doesn't matter which way round you've got it, as long as your capacitor is the right way round when you connect the wires to it, Outlaw. Yeah, polarity makes no difference until you connect it to the capacitor. If you connect the capacitor the wrong way round, then it'll go bang. So let's go back to our schematic then. In fact, there's another schematic here, but we use this one. So really, we want to check C23 and C20. What's this one here doing? C21. That's something to do with this. 31. C18 as well. 18, 20, and 23 are all connected to ground from, well, it's positive. It's confusing as hell, isn't it? I mean, basically that is connected to here, isn't it? Although they don't show it on the diagram. So we definitely need to check C18, 20, and 23 for sure, just to make sure they're okay. So C18 is that little tiny thing in there, I think, isn't it? Oh no. Hang on, C18 on here. No. Ignore that. C18 is not an electrolytic. So C20 and 23. And that little one that I'm assuming is going to cause a problem is C11, which is this one here. I reckon C11 is going to be bad. 2 microfarads. That's my favorite for being bad, C11. But we'll check C20 and 23 a minute. See how we get on. So C20, where are you? C20 is this really screwed up one here. I think it's that one. Yeah, C21 there. So it's this one here, C20. And that is 160 microfarads by the looks of it. So just disconnect this one leg here and see how we get on. Oh, don't tell me you want to stay on there as well. We've got 2 things through the same hole again. Come on. Okay, that's disconnected from the trap, I think. So we should be able to get to the tester on it. So what do you think it's going to be then? 160 microfarads. Place your bets. Eyes down looking. And C8 as well, Ricardo, potentially. Let's have a look where C8 is. C8 is in the AGC, isn't it? that's from the positive to the AGC feedback, I believe. But it does go through R6 to ground. I mean, potentially they could all be bad, couldn't they? It is working okay. I mean, I'm just looking to see if there's anything. Yeah, probably C8 would be a good idea to change, because if the AGC circuit's up and duff, then it will knock the sensitivity of it. Also, C11 would affect the operation of it. So yeah, C8 and C11 are definitely worth doing. We haven't got a lot of capacitors in this, to be fair. There ain't a lot, is there? I mean, how many have we got? 1, 2, 3, 4, 5, 6 caps in it. I think it's definitely a radio worth saving. How are we doing? How are we doing? Let's push a button. $209.9. Outlaw's got 200. I think it is the Theo Outlaw. I can't pronounce it. I think it's Theo Outlaw. How far is that out? Are we more than 20%? Well, saying that, these are probably plus 50%, weren't they, back then? So 160 plus 50% is 240, so it's less than 50% out. That's 20%. So it's more than 20% out. The problem is, what do you put back in place of it? I don't really want to go lower, so you'd have to go to what, a 1... What's the closest to 150? Sorry, to 160. I've got some weird sizes in here. So I've got a 180. That's probably better, isn't it? is 35 volts. I wonder what the 180 would read. So 180 is still within 20% of the original, if it is 180. Oh, 166. How about that? We'll have that one. Yeah, we'll stick that one in, I think. Let's do it. It is out. I think if it's fairly close, then we'd leave it in, but it is a fair bit out. Where's the other one go to then? The other one goes over to here, which is in amongst all this nonsense here. It's not getting it. It ain't doing that. The old outlaw. Oh, the old outlaw. Ah, right, got you now. Yeah, ESR would be better, wouldn't it? That's a Panasonic something or other, I think, that one. Good caps. one thing about this engineer thing, it locks up for a pastime. Got 3 wires going through the same hole here on this one. I can't see properly because I haven't got my goggles. I hope I haven't left them on the job, that's all I can say. So I'm going to have a look on the micro. See which one it is. Come on, where are you? I think it's that there. Yes, it is. Oh, yes. I wanted to try and keep this fairly original if I could, but you know. So that's the negative, and that's the positive. Well, the negative side of the cap, positive side of the board. So confusing. Come on, out. I've disconnected you. You've got to come out. You've got to go. Let's make sure I solder that red wire back on there, which is the speaker. Otherwise, we'll be in all sorts of trouble. Let's connect it to. Yeah, it's the same one anyway. That's done. So the job on that wire. Snap that one off. Okay, that's that one done. Now, what was the other one we were going to check? C23 is this one here. It's probably the same. Yeah, another 160. This is a different way up now, so it's this one here. This volume pot as well is really wonky. I think we've lost yeah, we have lost some that look. But that would explain why it's wonky. That would explain why it's a bit wibbly wobbly. seems to be a bit of a lack of Perdio radios in my collection, really. I've not got many. They're all a little bit quirky, the Perdio stuff. I think it was part of the Philips group in the end, wasn't it? Okay, what do you think on this one then? Another 160. Same thing. Eyes down looking. What was the other one? 208, wasn't it? Is this one going to be good? Another 160 then. The old outlaw is going for 205. He knows. Oh, Tim and the outlaw are the same. One of you's got to move. Aaron's 2005 microfarads. Wow, that's farads, isn't it? No, it's not farads. 200. So Tim and the outlaw. Outlaws folded first. No worries, Aaron. You were on 205 as well, were you? I'm on the water here. One thing with the aircon, it does dry the place out. Are we ready? Let's do it then. Oh, well, it's not in circuit because, let me just make sure I'm not in circuit there. Ah, okay. No, it must have been just touching. 225, that one. Yeah, that's a bit of a stretch too far, isn't it? 225. Let's pop another 180 at 35 volts in. Bit overkill at 35 volts, but you know. So we need to make sure we get this one the right way around this time. Who was 225 then? Who was closest to that? There's a ground going in. Its ground is going in here with all this lot again. There she blows. So ground is to that resistor. I'm getting out. Ground is to that resistor there. What I just do with that cap that I got there? How's your place coming back together, George, anyway? Have you got yourself built back up again yet? You're going to treat us to another video at some stage? Bit of an update? Let us know how you're doing. Hope the good lady's okay. Okay, that's that one. Right, so both of those, one was bad, the other one was borderline. So let me do the one that I fancy over here, this one. This is C11. See what we get from this one. C11. Now, according to the circuit, this is 2 microfarads, and it is 2 microfarads. So 2 microfarads, people. What do we think? Hang on. Am I connected onto the trees there? Yeah, I need to be connected to there. Okay. Let's put that in. Right, 2 microfarads and eyes down looking. 6.8, 12. Benji won it. $1.5. Bob thinks it's gone low. Okay, interesting. Interesting. So say in the circuit it is this one here. Upside down. Still upside down. What? So it's connected basically between ground and D1. You can see that the aircon is knackering it up. So it's in here, C11. So diode D1, it did say that D1, where did it mention D1 down here? It's saying that damping is a damping diode presenting a high resistance shunting the primary of IFT1. So if this one is out, it's going to knacker up that shunting of the primary of IFT1. So that's on the center tap. So basically the center tap goes through there and onto the primary of IFT2 as well. The C11 would definitely have an effect on that if it was bad. Okay. Let's see what it is then. It's just turned 30 here, George, I think. Just turned 30. I think it got up to 30, 32, 34 yesterday. Right. Do it. Interesting. Hang on, we're not connected. That would give it away, really. We need to. Where is it? Connect to there. In circuit leaky. Well, yeah, it might be. Yeah, it's saying it's in circuit leaky, but I think that's telling fibs. Let's pull it. Or am I going the wrong? Hang on, am I going the wrong way with it? Where am I? Let me try that again. Let me try that again. I think it's just touching. I think it's just touching that. It's not even, it won't even measure it. It won't even measure it. Let's get it out and have a look. I'm just trying to make sure I get this the right way around. So that's the negative there. That's the negative on that ring. This is the positive here. So I think this one is totally knacked. Let's do it out of circuit. It's not even measuring, so that is absolutely knackered. We can try it on. Let's try it on the LCR meter, see if it reads anything on that. $47 picofarads. Anybody have 47 picofarads? Oh, it's moving because I got my fingers on it. Yeah, 47 picofarads. Anybody get that one? So the lowest will get it on that. The lowest will get it. So Bob with his 1.5. It's probably right. Tom and Susie, how you doing, mate? It'll measure a 2 microfarad, but it won't measure that low. $47 NF. Was it here? I can't remember now. Absolutely shot. So we want a 2 microfarad. We don't need 100 volt. Oh, we've got one of these low ESR Chong Chong. Chong Chong, low ESR. Let's see what this one measures then. Being it's low ESR, it's going to be high ESR, isn't it? Yeah, 2.23. Low ESR, it says on the side there, look. It's saying that the lower the value cap, the higher the ESR, so that's probably about right. So I was dead right in saying that that one was going to be absolutely knackered. Oh, steady. Right, so that one had to go that way, around there. That one there, and that one there. Solar Arms decided that it's been on for too long, so it wants to have a break. Okay, what else have we got then? Well, we've done 3. We've only got 3 left. What's this one here? Can't quite see that one. So this one here, this blue one is C22, which is another 160. That's in the output. That is in the output. So let's get that one. Looks like it's across here. So we're looking at a 160 now then, people. Let's make sure I get this the right way around. So positive is to there. It's going to mark that a minute. That's the positive. Okay, so another 160 then. What do we think? So one was, the last one I think was 225, wasn't it? There was 208, I think, the first one. What's this one going to be? This is it. This is probably the hardest used cap in there. Because it's right on the output. So it's going to be probably the one that sees the most action. I'm going to pop this one in while you're contemplating that. There. There. It's real strange how these things are soldered in. Hopefully I get them the right way round. I hope that wasn't something that just bit my leg. It felt like it. There we go. That's that one done. 160. God, Tim's gone 230 now. That it could be. I mean, it could be. Let's have a look. $242. There you go. That's got to be Tim then, isn't it? Any dates on them? I don't think there is on these blue ones. 60 to 70 degrees. 3N. No, there's no dates on those. I don't know if there's anything that's dated on the radio itself, to be fair. I don't think these sort of caps don't tend to have the date. The tuning cap might, but it's potentially underneath the radio. IF cans haven't got any markings on them. So now I can't really see anything that's likely to have a date on it. We've only got 2 caps left. So let's get this one out next. This is 125 microfarad. And this is C21. No. No, yes, it is C21. C21. C21 is on the driver. Let's get this one out and have a look then. I think we're at the stage where we're going to just do them now, I think. No point just leaving one in, is there? Okay, I'm not putting expensive capacitors in this. Just putting in ones that will do the job. So this is my radio. It's not is it up for some? I might get rid of it. I need to sort of get rid of some stuff. So that's the positive there. This is the negative over here. So what's the closest I'm going to get to 125? What I'm going to put in there, I've got a 120, which is under. Closest to 125. What can I put in there? Any ideas, anyone? Oh, shit. Pardon my language. Whoa! I just knocked the computer then. Did C22 get changed? Yes, it did. C22 was one of the 160s. We're on C21 now. Hopefully we're still here. I'm just having a look, see, because I've got some strange values I ordered in recently. Actually, no, these are standard sizes here. 150s. So I've got 150s. Would I be? What am I banging on about? Yeah, 150 is going to be probably the best bet, isn't it? 150 is going to be, I reckon. Let's go with the 150. Yes, yeah, I've got 150s, Anthony. Great minds think alike and all that, isn't it? Where are my... I have got some new 150s in, but I'm sure I've got some somewhere. 150s there. It's probably in my stash over here. Yeah, I've got a couple left. So I'll pop a 150 in there. So that is that away round. So 125 still on the cards to guess. Let's pop this one in while you're still guessing on the 125. Will it be more than the 150 I've put in, or will it be less? Should we have kept that one? Let's find out. If I can find it. Here goes then. Oh, 294. It was close as that. Is that Mrs. Cruncher right here? No. It's been fun getting in there. Some idiots have parked right the way down through the driveway. Right, 294. That is absolutely shot. Are you going to build some 200 kilohertz boards? Nice one, Derek. You can make a 198, couldn't you? That was Derek, was it? 175. We got Ricardo at 190. $166. I think that's Ricardo, isn't it? I think that's you, Ricardo. That one was shot. That was well over the top. Where was that one again then? C21. That was... So, all of you that are in the know then, tell me what this capacitor would have done. So, C21 is here. This is C21. So it's on the emitter of TR5. Also connected via the base of TR4. Is that some sort of bias in down there? Anybody got any ideas on the function of C21? What does it say up here? Say what C21 does? No, it doesn't. It doesn't say what C21 does. It's definitely in the output circuit, so it might, is it something to do with tone, maybe? Is it a tone capacitor? Can't see any tone caps in here, so it could be tone, that. C21. What's the answer? Baz is saying it's to increase the gain at audio frequencies. Okay. Bob is saying improve the bass response. AF decoupling. Same as a cathode bypass on a real radio. Tom thinks tone. It's knacker, whichever one it was. But there's only one more, and this is potentially going to be one of the harder ones to get out. No, maybe not. That's this one up here. So this one is this little blue one up here is C8. So let's have a look where C8 is a minute. Ah, okay. This one is an important cap. It's down here, look. So this is the AGC feedback line into TR2 C8. Yeah, DC component decoupled by R10 and C8 and fed to the base as a controlled bias voltage. So yeah. Yeah, important cap. But the radio is sort of working now, isn't it? It's pretty good. Let's get that one done then. Seems to be a bit of a weird angle here. Then we've done them all. So I was willing to give that the benefit of the doubt, but once you've done a couple, steady. Once you've done a couple caps, you can get a feel of what the whole set's going to be like, really. And this one wasn't going to be good, was it? I think we had a couple there that would have been okay. Well, they're all okay because the radio still worked, but right, which way round is this? So the positive is that top one there. It's a positive. So this is what value? Positive at the top. Remember, positive at the top. A 10 at 16 volts. Positive at the top. Can you remember that? 10 at 16. Gonna stick an axial back in there. Just easier. Safe stretching the legs right across. Twang. Could have been bit or something here. So yeah, I was bitten under the desk. Nice. I've got me zapper here as well. Right, 10 at 16 then. Let's do it. Last one. Pitco, how you doing, mate? Great. Bitten right on my knee joint underneath on the back. Oh, it's going to be great, that. Thank you. Mrs. Cruncher back here. Probably some kids' party going on up the road, I would have thought. Right, how are we doing? So I will stick a link to Mark Hennessy's page in the description of this radio for anyone that wants to read along later and see what's what. I don't know that I can alter it at the moment. Still something biting me here. No, I can't alter it at the moment, I don't believe, while I'm streaming. You had speckled hen. Nice. I had butty batch today. Or butty back today. Wye Valley. Right, how are we doing on this 10 microfarads? Everybody had a go? Let's push a button then. Okay, so yeah, the radio was working okay, so that one is all right. 11 is fine, 4.8 is fine. A little bit high maybe, but wouldn't have stopped it working. Right, let's do some things then. What are we going to do here? I could potentially couple my external aerial into here. That would probably give us a better better signal source. I could connect my test setup to the speaker so as we could trim the IF for maximum smoke. Certainly we need to fix the aerial coil because that's significantly altering the signal. So yeah, that one was absolutely knackered. That was probably the worst one. And I think one of these, the 125, had gone up to 200 and something, wasn't it? 260 odd. So pretty bad, most of those. Stick this back on. Again. Brilliant. Yeah, we need to just melt that. We should be able to tell from the signal strength how good that is. Let me just pop mine. Test set on. Could just use an output meter, really, couldn't I? Or an AVO. It's a bit of a tidy up, and then we'll do a little bit of alignment, and then we'll call it a day, I think. Cover up the dial cord, yeah. It has been breezier here. I thought I said something else. Scratching pen fibers. No, I've been bit on the back of my leg. This is the problem. You've got to have the windows open to get the air through, and they just eat you alive, don't they? Eat you alive. See if it still works after I've recapped it. Not had much luck recently. Should have improved it. No end, surely. Right, let's not do that a minute. Let's just rejig my power supply back to normal. Come on. What are you doing? Why are you doing this to me? Thank you. No, stop it. Right, negative. Possible. Tracking. Oh, let's get about 25 volts down to 9. Current limit down. Let's have a look, see what we're doing. It's that, Mrs. Cruncher. I can hear vehicles going outside. Well, maybe not. Yes, it is Mrs. Cruncher. She's loving that traffic out in the driveway. Mrs. Cruncher's in the house, people. Look out. Right. Find the hole. Oh, more volume. Straight away. No reception though. Let's turn a few things off a minute.
Rarely see any being that much pushed around the block. Sliding descent on grass. I mean, usually you see you constantly attacking.
3 game points. Only needs one of them, so there was some crucial power again from Zverev in that game, but didn't have full help a lot. 6-5 final set.
Let's move that aerial coil. That's about the best I'm going to get there.
Given that it wasn't the earliest of start today with a 4 PM final, may well have been watching the England.
Let's look at the IF alignment then a minute. So, okay, so it says when it's fully closed, Should align with the left-hand side of the scale, which it does. Does it on here though? No, I might have moved that because I did feel something give. But it does definitely line up with the left. If I go around that way, it lines up with there. What does that look like? Where does that get us to? Yeah, probably not far off. Yeah. Maybe I didn't move it then. Right, what do we need for the IF? What is the IF? Oh, it wants to be connected directly to the base of TR1. Wow, okay. Let's do the IF alignment then, and then I think we'll call it a day then. So TR1 base is basically on C2. C2 R2 R1 junction. So C2 is this one. So it's collector, shield, base. Well, that's C3. I wish I hadn't put this bit back on there, look. I mean, it's going to be difficult to get a capacitor in there. Basically, it's that. Is it that one? Yes, that one, that there, I think. I might be able to get a wire on that. Let me have a look a minute. What's it asking for? A point? A 0.1? What's a 0.1 when it's at home? Is it 103? 0.1? Go on, quick, tell me. A 0.1 is 100 NF or 104. (102) 222 104. My little bluey. (104) 102 100. This is my go-to. These capacitor charts are absolutely godsend to me. I can never ever remember them. Never. I don't want to remember them. I don't want to learn. I don't want to do any more learning. Done enough. Right. Let's see if we can't get this soldered to the base. How low can you go? Ideally, I want a little tiny bit of insulation for that. Save it shorten out on anything. Can I find any? No. But that white stuff would be perfect, really. So we'll just put a bit of heat shrink on it for now. It's good that you're connecting directly into it because it does away with the faff of the loose coupling. Just you don't know really when you lose coupling where you're gonna go. So let me just check that again. So the base is there, going to where is the base? I believe. You can't really see this because it's in underneath this shield, so that's the coupling for the sig gen. So let's just get a signal generator coupling type lead going on. Going on. So frequency we want is let the audio meter. Can I stick the audio? Yeah, sod it. Let's do it. Let's just do it. Or do I connect this the other way around? I don't really know on here. I always get confused with this. No, that's the speaker. Because it's positive ground. That's connected to there, that's there. So I want my .470. What are you doing now? Come on, don't do this to me. This has been playing up recently. I think I've got a dodgy relay. Right, okay. 470. 470 megahertz. What do we want? IFT for maximum output. So we could connect our output meter in. Let's try that, shall we? I've used it for ages, so let's get the old girl out. Happy days. Now we're talking. So what is the speaker? The speaker is L6, 20 ohms. Really? A 20 ohm speaker? Really? I am reading that right, aren't I? Unusual. Anybody ever heard of a 20 ohm speaker? So L6 is speaker coiler. Speaker 20. Hmm. Yeah, 20 ohm. Wow, okay. 20 it is then. So I've got to configure this thing for 20 ohms. So we can do 20 times 1 on that scale. Or was it that? Careful. Is that going to short onto anything? I don't think it will. Let's grab it from this side. Let's get my ground up. What are we on? Are we deviating? Right. Why can't I hear that tone then? Yeah, I got a funny feeling I'm the wrong way round. I think I've got to connect. I don't know. Why can't I hear a tone? That's worrying. Should be able to hear a tone on that. Why is my signal generator not outputting? Should be 1 millivolt there now. Modulation frequency 1 kilohertz. It's not outputting anything. Why not? No, wrong way around. Does that need to be on? Yeah, not on there. What is going on here? No, trust in this. Ah, hang on. Try turning it on, that would help. So I'm hearing a tone between these two. No, I'm not. I'm just hearing a load of noise. Why is that then? What's going on with mine? What is going on? You don't want to hear the tone. Okay, that's dropped off, so. That's just a load of noise. I don't think my signal generator is outputting anything. Seems a bit strange. Let's try that. Is my signal generator playing up? Can't hear anything coming out. What's going on with this? I don't appear to have any output from my signal generator. That's a pain in the backside. Just try something else a minute. Let's try a loose coupling it. So I'm definitely 470 kilohertz. Just double checking. How are you all doing? Jim, how are you, mate? Memories of the 60s, yeah. Definitely not cracking up here, am I? AM signal generator definite. TR1, unless I'm not connected in the right place. You know, maybe I'm not connected in the right place here. So I'm going to try loose coupling it a minute. Loose couple. Let's loose couple this baby in. Come on, loose couple. See if we've got anything now. Just a load of racket. Let me just turn that back off again. Let's try. What can I do this on? Times 10. Let me think. No, definitely, I'm sure that's 20 there. Times 1. That should be. No, it's just noise. Okay. We need a sense check. We need a radio that's working a minute. We need a radio that's working. I don't know what the IF is on this though. Let's just try RF and let's go frequency 1 mag. Well, it's working. It is working. So why can't we induce a signal into this then? Have we got something connected it up wrong? That's our positive and negative. So audio output meter. Let's just connect the speaker back a minute. You never know, it could be my output meter that's a problem. Green is the ground. There is the positive. So let's try 0.470. Let's connect the ground wire on. Well, it is going through there. It's weak though. All right. I think what we'll do is we'll just connect the scope to it, I think. I should have got in that lovely scope that Alex gave me, really. I must connect that up. All the gear. Derek's off. Let's connect that. Let's turn it on. What are we on here? We want scope. That's trigger level. We don't want trigger level. We want the. Come on. Oh, I've got to get the manual out and sort this scope out. Come on. It's not the best waveform, is it? It ain't the best waveform where you can't see. It's not the greatest. Let's it's got to be IFT 1, 2, and 3, isn't it? I don't know why that output meter's not working properly. IFT 1, 2. That's a 1, 3. It's not great, is it? And that's 4 millivolts I'm throwing through that as well, so it's not a weak signal. That should be absolutely rammed. Maybe it's because I got the volume down too low. Try that again. Apologies for the noise, people. Well, I got a bit out of it, but not a lot. Hasn't made any difference. Oh, what a racket. Let's turn that off. I can't hear myself, this is a problem. Just trying the IFs with it live. That IF can's very which is the aerial trimmer then. So that is these two here. That's about as best as that's going to get. That's as good as it's going to get. Let's chuck the coil on it through the external area and see if...
Here's Yannick Sinner trying to plant a couple more serves onto the sideline, and he's at 40 love on his serve.
External area, we'll see.
Zverev opens his shoulder again, but he doesn't land this time. He nets. Going a little bit like the first set. 2 games all, but so little between them. It is a great game from Sinner there to listen to that interview. Played a couple of great shots. Zverev really had Sinner all over the place, no run, but Sinner does it.
Shush. I'm just going to connect up the external aerial directly to it rather than with a coupling coil. See what that does. If I can get any of these wires out here. Doesn't matter which way round these are.
Absolutely, and look, we've been talking about it previously before the start of this match. It's what kind of level Zverev is going to bring today, and we have the answer now. But it's great to see Yannick changing his...
Yeah, and others may be very much on the same trail as...
I mean, you almost feel like you have no answer back.
Another huge...
Now it's working.
Box, and he's just knocking them over. Knocking them over? They'd be exploding.
It's fireside press, so
I mean, the
type of exercise he was doing before the...
But it seems, I'm reading this side of the waters, that it's been well received at what he's done there, and the USA want to keep him on. So that'd be an interesting call by him, because obviously he's got the choice there. It sounds like he's got a contract in front of him. I'm guessing if the public are with him, he might stay. What do you think?
Wow, I think that's about as good as we're going to get that set. Interesting though. Nice little set. But I'm going to call it a day at that. Mrs. Cruncher is home. Sounds like all the neighbours are going, which is all good news. Oh. Next Hazeltine loop. Yeah, that's a beautiful thing, isn't it, Ricardo? Cheers, Martin. Right, let me just catch up with the chat, because I've been ignoring it, trying to get it. Trying to tune this thing up. The cores are rubbish on this. I mean, they're not really biting into the formers. They're moving. I can push them through. It's not great. Graham's RFI, yeah, it's a lot of noise in here. So I can get them using the external aerial, Stephen, but indoors here it's pretty bad. I mean, If I put this one on, for example, I can just about get that here, but if I move it away from all the stuff, it says like SSB that. Yeah, 909 is usually quite a good one. Something that's making it sound real weird and garbly. It might be this light. Could be the computer. Yeah. Medium wave is rubbish here. It's alright if I got the external area on, but there you are. Cheers everybody. Let's just get back to my main chat. Hope you've enjoyed that. A little bit different. Bit of playing about with the little old Perdio from 1966. The noise cancelling has notched out the 1 kHz tone. Did it really, Baz? Tell you what, it's got hot again here now. I've turned that off. There you go, people. Hope you've enjoyed that today anyway. Give it a thumbs up if you have. And as I say, another radio back working again. That it wasn't working before. It is now. We've zapped it and capped it. So I'll catch you next week, if not before. Bye for now.